Okay, so I'm gonna get started. There's a good bunch of us in the room now. Some really cool names and faces that I'm familiar with. So I'm really excited for this. Thank you all for being here. I want to make sure, first of all, you can all hear me this time, because I had a bit of an embarrassing moment in the first one where I was like going through this presentation and my mic was still on mute. So please give me a shout out. Please give me a wave if you can hear me, if you can hear my voice, so that I don't go off on this whole presentation while still muted, right? So you can hear me, all right? Okay, good. That's one of my embarrassing blooper moments that I'll keep hidden forever. Welcome all of you to the Rust Crypto, and for today, Formal Verification Interest Group Sync Up call. I'm your host, Ernest, from the DevX initiative, and I'm really excited to welcome you. So this call serves as a forum and a roundtable for Rust developers interested in cryptography. As I just said, this is a special edition of this Sync Up call where we're also opening up the floor to those interested in formal methods and formal verification in Rust as well. The idea of that is to help bootstrap the formal verification community in Rust so that there can be a sister organization, a sister group that has many of the same ideals, ambitions, and goals for Rust as well. The purpose of this call is to foster dialogue within the Rust crypto ecosystem. This isn't a showcase for individual projects. This is about us coming together as a community to figure out what's needed, to do some blue sky thinking, to work towards collaborating and figuring out what is needed in the Rust and formal verification ecosystem, subsets of the Rust ecosystem, to make it all better for everyone, really. We want to explore the landscape, diagnose what's needed, and create community resources collaboratively. Regardless of what project you're with or which company you work for, it's about coming together to make sure that we can all help each other holistically. This Sync Up call is facilitated and made possible by Concordium. So I'm really grateful to them for them enabling this to happen. The DevX initiative is an initiative from Concordium to embed themselves in the Rust ecosystem, and I'm really proud to be working on that. You can find out more about that and follow Concordium, the DevX initiative, and of course Rust at these Twitter handles here. I am hosting this Sync Up call with Tony Arcieri, who you all know from Twitter, the legend. Please follow Rust Crypto as well, who are a part of this organization, the Rust Crypto Interest Group. I'm also hosting this with Diego Aranha and Bas Spitters from the Concordium Blockchain Research Institute of Arhus and the University of Arhus as well. I'm really privileged to be working with them and to have them on board with this endeavor. Tony, Diego, and Bas are some of the most prominent people working and actually contributing to this space. And it's really exciting to be able to have them as part of this. I'm going to hand over to Bas to allow him to speak more on his ambitions for the Rust formal verification interest group, and to also speak more on how we can make that community happen. Thank you, Bas. You want to say a few words?
There it is. Thank you, Ernest. I've been involved with Concordium for about 3 years now, I think, from the start, and from the COBRA the COBRA Center also from the start. I'm leading the part on formal verification and smart contract languages within Aarhus University. I put the link. Sorry, I shouldn't be looking at chats because that's distracting. But the link to the COBRA Center is in the chat. I've been working with open source software for about 20 years in verification and programming languages, mostly in COC. So COC is a state-of-the-art proof assistant, so the main tool in formal verification. We'll talk more about this in a minute. I've been in the program committees for POPL, CPP, ITP, Certified Proofs and Programs, Interactive Theorem Improver, the COC workshop. I've organized a number of these kind of meetings. I'm very excited about Rust. We've been using it for some of our work in high assurance crypto, both the fiat Rust before and we've been started to contribute to the HexSpec project. I'm really excited because it has a very, it really fits into the ML family type systems, and I've been working on type systems for a very long time. It's a nice layered language, so even if we cannot do the whole huge language in one go, there's a lot we can do with smaller languages. And there are a lot of projects already around formal verification of WebAssembly, LLVM. So we have people from Rust Belt here, which is also very exciting. Unlike C, there's no precise semantics for Rust, but now fortunately we have this Virocene project, which tries to actually make a Rust standard. So that's also quite exciting. So I think, and we've been discussing this with a small group of people, there's actually a bit of interest to have a formal verification interest group along the lines of Rust Crypto Group. Obviously, that there was such an interest group before, and it seems to have petered out a bit. So I hope we can also build on that and try to restart some of that. I'll briefly say, so these are some big ideas, but just to be somewhat more concrete of what we're actually doing within the COBRA system. We've been using the fiat crypto system that was discussed last time, and particularly fiat Rust, which allows us to generate fast Rust code. And this is in collaboration with Diego and our students. We've been contributed to HexSpec, and this is a shout out to our research assistant, Mikko Milo, who has been working to the very last moment to actually get the COC backend to work. And now there was, as always with open source products, there was a small change in the language, so his code didn't compile at the very last minute, but it will be done next week. So then we actually have a backend for HexSpec also. We had students building the BLS curve, both in HexSpec and combining it with fiat Rust. And we have a framework for verifying cryptographic security, which we're also going to connect to the Rust infrastructure. That's part, and then we're also working on verifying smart contracts that are written in Rust. And I can say more about this later. One exciting thing is that we can write dependently typed programs, translate them to Rust, and this actually runs faster than OCaml. So this is probably something that the Rust community likes to hear. I mean, being better than other languages is always fun.
Yes.
And we like to connect all of this to high assurance cryptography also. So that's just a very quick overview of the kind of things we're doing.
Amazing. Thank you very much for that, Bas. We're looking forward to getting more into that. Sorry, Bas, if I could just ask you to turn down or mute yourself. Thank you. And yes, we are looking forward to hearing more about how all of that interplays with everything that we're trying to achieve. I think there are some great overlaps with everything that's going on in the Rust cryptography ecosystem and the Rust FV ecosystem, and even just having them bleed into each other and exploring all of those wonderful possibilities. I think it's really important. So getting people in the room together, getting them talking, getting them understanding what's missing and what's needed and how we can all collaborate to help each other is something that I'm really excited by, and the DevX initiative is really excited about. So again, this is just a lot of fun and it's really exciting. So the Rust Cryptography Interest Group, and these calls all fall under the Berlin Code of Conduct. Again, it's just really simple, basic human being stuff that we will do. And it's important that these conversations are open for robust debate and even, you know, contentious differing viewpoints, but they have to be done in a framework of respect and in just with simple, again, simple, basic, decent human being stuff that we all do. So we want to encourage robust debate. We want to encourage robust conversation, but just be, you know, just be mindful of how you come across. The next really important thing is how we manage the hand raising and question asking etiquette and protocol. All of us having to experience Zoom calls every day of our life know how unwieldy they can be, how awkward they can be and everything else. So what we've arranged and adhere to here, and we're still trialing it out to get it better, is using your video as a way of raising your hand. So if everyone could switch off their videos, bar the hosts, of course, if you want to keep your video on, that is an indication that you want to speak. That is you raising your hand. If you want to make a follow-up point and you want to ask follow-up questions, then you keep your video switched on. If you don't have video on your laptop or device that you're using, then use the Zoom hand raise feature and keep that switched on to indicate that you want to make a point and you want to continue making a point. We won't do like a round call of icebreakers for everyone to introduce themselves, but it would be really nice if you come up to ask a question, you just give a quick TLDR of who you are, which project you represent, if you do, and just a little bit of background on yourself before getting into your question. If you don't want to, if you feel too shy to ask a question in that manner, you can still use the chat. I will keep an eye out on the chat for any really salient questions that need to be asked. But the primary position will be given for those who will switch their video on and raise their hand for a question. We understand that everyone has different personalities and isn't as outgoing or extroverted as maybe myself, but it's important that we also look for those questions in the chat as well, as much as possible. So we'll try as much as possible to keep that as a factor as well. The agenda will be the opening address, which I've just done. We won't really bother with introductions and icebreakers because there's 35 people on this call. That'll take forever. But what I will start with is a recap of our first call, and then we will get into some of the things that we're going to focus on today. I think a lot of this conversation is going to center on high assurance crypto because of us hosting the Rust formal verification group as well. So that's where we'll really kind of get into the meat, and then we'll close up on the hour with some closing remarks as well. I hope this all makes sense, and I'm really excited to get going. So what I will start with, and hopefully this all made sense, is recapping on what we discussed in our first call on the Rust Cryptography Interest Group site. A lot of the common themes relate to formal verification as well. The first thing that came out, oh, and just before I forget, this is being recorded as an archive and it will be uploaded on our YouTube channel. So just please be aware of that. You would have gotten a notification when you entered the room that this call is being recorded. So if there are any issues with that, please message me, and then we'll work something out on that. But this will be uploaded to the DevX YouTube channel as an archive as well, just to let you know that. So coming back to our first call, we started with some of the common themes that came out from the hacks workshop. There were some really, really good points made by various people on that. And one of the key things that came out was people want higher assurances, constant time operation. And that's something that is, again, a reoccurring point and reoccurring theme throughout the call last time. But I wanted to open that up to Bas and Diego first, with Tony. So we'll go with Bas, Diego, and Tony to kind of elaborate more on that. Diego, I think you were the person who really made that point as an opening on the last call. So maybe you want to kind of just recap and elaborate more on why people want higher assurances and why that's needed in the space now.
Yeah, so should I go first then?
Yes, yes.
Okay, yeah. So I think that there was a big overlap between the people attending the call and the people who usually go to the Hex workshop, which led to we discussing themes in this intersection between crypto and formal verification on the first call. We also talked about creation of crates and low-hanging fruit projects that could get the interest group moving forward, which I think are relevant too, not necessarily for today's call, but to keep in mind so we have a more productive relationship. But yeah, high assurance cryptography is cryptography that we can provide guarantees for correctness, for correct handling of exceptional cases, and also for sidechain resistance to some extent, right? Just minimally constant time execution, so it's not vulnerable against timing attacks. And this is especially important in places where crypto has a higher threat model when it's running. Bas will probably make that point, so I won't elaborate much, but when it's running on smart contracts or infrastructure that's immediately accessible to the attacker, but also on embedded systems that the attacker can just capture and collect sensitive signals from them on the field. So designing for that worst case where the adversary is quite powerful makes rationally, it makes sense for cryptographers and crypto engineers to worry about.
Yeah. Absolutely. Bas, would you like to come in next?
Yes, I posted some links in the chat. What we've been using is Fiat Rust, which is a tool chain that was developed at MIT, and we've been contributing to this. So this guarantees constant time code, because there's no possibility to do things like function calls and loops. So it's all straight line code. That also means that it's limited. The advantage is that it's system independent, and it's portable, and it can. There are many backends. So there's a C backend, a Java backend. That also means that there's a bigger group of people that can actually share the burden of creating and maintaining this library. So I think that is an advantage, because we want to have. So what currently one would need to do is to actually write the glue code, because you still want to do loops. What we've been doing is look at an extension called Bedrock, which also is a way of. It's a small language for low-level code, which does allow you to make that extension. Of course, there you still need to be very careful for the that you're not leaking secrets in that way. Another thing, as I said, is we're looking very much at smart contracts. And in general, there have been huge accidents with smart contracts where people lose millions of dollars because of the one-line programming mistake. And this is not only smart contracts; it's also in high assurance crypto. There was one of the privacy blockchains. They actually, a very serious project that also made a small programming error, which would have been caught by high assurance cryptography. So this is a very important topic. What we have is one testing and verification framework in the COG system, which allows us to. So in general, so it has long been a tradition that one can translate things from the prover system, from the prover system to Scheme, Haskell, and OCaml, and we now can also do Rust in a limited way. Basically, so we have a functional program and we can translate that to Rust, and this actually works very fast for some limited cases. Currently, we do this by leaking allocating all the memory using arenas in the beginning. And then when the smart contract, typically when it ends, you just release all the memory again. And we would also like to connect this to high assurance cryptography, because typically in smart contracts, there's a limited part where you do cryptography, and that part you want to be absolutely certain about. That's also correct. So that's another thing we're working on.
Yeah, thank you. Tony, so from your perspective, it would be good to know, like, just to recap from what we've already spoken about on the first call, why high assurance cryptography is such an important need in space for everyone, both people working in blockchain space and also for other things in general. And also, if you could go into like talking about some of the interplay between the formal verification side and Rust cryptography side that needs to happen to ensure there's a holistic kind of approach to this. It would be great to hear from you on that before we hand out to the rest of the audience to participate in.
Yeah, sure. So I'm more of like a in the trenches implementer. Trying to write practical implementations that you know, people would actually use. So Rust Crypto maintains some of the most popular ecosystem crates like AES, AES-GCM, that kind of thing. SHA-2 is another good example. So one of the hardest things about implementing cryptography, especially as we work on like performance-oriented and SIMD backends and all that stuff, right? The hardest part is knowing you've actually implemented it correctly. So, you know, there are test vectors, and test vectors are kind of like a smoke test to me, right? Like they tell you it isn't completely broken, but they don't tell you that it's actually correct. So that's where, you know, I have gotten interested in how we can take some of these things, some of these tools for formal verification, and apply them to a real world kind of implementation, right? Like one that has all these like bells and whistles that people actually want to use in a practical implementation. So I've attended hacks for the past couple of years, and I guess there have been two big things that I really like that have kind of that I've learned about at hacks or that have come out of hacks. So one of these is what Bass talked about, this idea of like synthesizing Rust code, like formally verified Rust code is a part of a project like Fiat Crypto. So I saw you dropped a link in the chat, but there are synthesized field arithmetic backends that you could use to build a elliptic curve implementation. So as part of Rust Crypto, I think we're going to start looking at some of those, incorporating those. So possibly a NIST P384 crate, which we maintain right now, but doesn't have an arithmetic backend would be a good example. Another, okay, so switching gears, another thing I really like that came out of hacks is HackSpec. So HackSpec is a subset of Rust that is amenable to formal verification and can kind of be translated into various other languages like F# or F star, is that what I'm looking for? And also, yeah, Coq, as was mentioned. So the idea that I like about this, so I'm obviously like not super into the formal verification side of things, but the idea I really like that I think HackSpec might enable is formally verifying the HackSpec implementation, and then over in Rust Crypto land, we can apply some other tools to do more like Rust to Rust comparisons to make sure things are correct. So that would be things like property-based testing and fuzzing against a formally verified HackSpec implementation. Especially with things like SIMD backends where, you know, it gets a little, unless you have like a symbolic execution model of like the entire SIMD backend, and then you have these like instruction fusions and all that stuff, right? So that's a place where I think it would be really nice to just compare our fancy fast backend to a formally verified Rust backend and make sure that we're not spotting any of these like really tricky edge cases where things might break.
Yeah.
No, someone asked
thank you. Yes, someone's asked a question for you, but I just want to, before we get into that, I just want to stay on this conversation thread. And then I'll ask you that question, come back to it. So Shady, please bear with us. We're going to come back to that. what I wanted to open the conversation up to everyone in the room is, so in regards to like tooling that we've just discussed, there are a lot of really positive things happening, it seems. There seems to be a lot of positive momentum with Spec and Fiat Rust and Fiat Crypto as a suite. What frustrations or what holes do people feel that there still are in space? And this is open out to anyone. If you want to just come on video, and then I'll introduce you. You can introduce yourself to make your point. Where do you feel that there are still gaps that are missing, even with all of the positive momentum that's happening? What more do you want to see? And this is open out to everyone. Again, please feel free to come off the camera, to switch on your camera, and then unmute yourself, and then you can kind of just say hi.
So I can kind of get the ball rolling here.
Yes, please do.
So, what I think hacks is kind of all about, and like one of the trickiest parts of all of this is a lot of formal verification happens in more of this like academic space, where it isn't directly applied to things like real world implementations. So there's kind of this gap between practitioners and academics, which has been kind of hard to bridge. So I think there's like a lot of, you know, like background knowledge you need to apply formal verification tools. And then even if you have that, there's like a lot of usability concerns about applying those. So I think just kind of traditionally, people haven't applied formal verification because it's too hard and that gap has been too big to bridge.
Yeah.
And that's, again, why I like projects like Spec, where you can get a good spec implementation. And then once you've gotten that, and once you're reasonably assured of that, then you can just treat it as if it were any other Rust code.
No, that is a really good point. And I feel like that's follow on to that is, how do we create bridges between academia and the academic rigor that has to happen with formally verified methods, and ways for that to be more accessible to industry, you know, just different industries out where it makes sense for it to happen. I mean, part of that is just an identifying phase where, you know, we figure out like, well, actually, these are the places where it really makes sense in industry to have some of this tooling used. But we also need to have those bridges between them built. Like, it would be interesting to have a conversation around, or to open up the conversation to how that can happen. I know Critical Section are doing some really cool things like that, trying to really, you know, push that forward. But you know, there needs to be more of an effort, a combined effort, you know, for that. How do we see that playing out? You know, again, how can we build more bridges? And that's open to everyone. Yes.
I just something I watched the video someone recommended, and it was saying about that people in science, in academia, sorry, that it's not science, and that like they only go for what's on the academic papers on, you know, certain journals or whatever. And he was like saying it was like pathetic or whatever. But the thing is, like, I'm saying in another context, say this is in crypto, in space weather, there's a similar thing. There's a guy called Ben, Suspicious Observers, and he has science community in the world, and he has the same problem with people in academia too. So I'm hearing the same problem, like, but just in a different context today.
Yeah.
Do you know what I'm saying? So they're quite, from what I can gather, it's quite hard to get that kind of going.
Yeah. Thank you for that, John. Yes, absolutely. And it plays out continuously in lots of different avenues and different areas. And this is why it's important to have. This is why it's important to have these conversations. Hi, Mike. Thank you for jumping on.
Yeah, and I'm sorry, I don't mean to cause offence. Just it's in space weather. It's just I'm hearing a similar kind of pattern. If you know what I mean. So It was just an observation, that's all.
Absolutely. Thank you very much, John. Mike, did you want to come in?
Yeah, let me just say a little bit about who I am. So I'm a principal scientist at Galois. So we're an industry research lab, and we've been doing cryptographic verification, for money, under contract for many years. I think that, so our background, we've recently done some proofs for Amazon, for example, which you might know us from. We haven't done too much Rust verification, but we're moving into that space. I think that observation about the gap, our model is that we do the proofs, and then we work with engineering teams to achieve those proofs. I would say there's still a very big gap in terms of, usability. So someone who's not a formal verification expert, I think some of these formal verification tools can be very challenging to use. I think there's a lot of room for kind of focus on that and improving that. And I think that there's really what we sort of need is kind of people who are enthusiastic to kind of be early adopters of those technologies and sort of come back with good feedback and come back with good ideas about how to make them better. I think that there's it's going to be a little, the technology is very powerful. And I think that the big gaps are really in the usability space to kind of get that stuff usable and get it useful. I think one thing that Tony mentioned that really resonates with me is, as well as formal verification, we really need to have good fuzzing and testing kind of tools around those things, so that we can have good on-ramps to having those formal verification tools be useful early in the design process. So yeah, I think it is certainly possible to, people do academia to industry things. That's kind of what Galois does, and I know other people do the same. But it's definitely there are some significant barriers there at the moment. There's a lot of optimism, but I think there's some barriers. Yes,
that was a really great point, and that was actually something that was broached in the previous call, but for cryptography specifically. Just looking back at the notes from that session, we spoke about getting started with cryptography in Rust and how that can be improved. Deirdre made a really great point that there's no cryptography in the standard library. There are no exposed cryptography APIs in the standard library. And I feel like, again, there's the parallel with formal verification. Getting started with that is one of the big hurdles to allowing it to flourish and improve, because it's, again, very daunting, it's very intimidating. It can be anyway, speaking from just myself, but getting started so that people can create that feedback loop is one of the big challenges in general. So I think that's a really good point. What ways do you see that we can kind of nerf the edges, not making it like easier, quote unquote is a word, but like, how can we nerf the edges in just getting started with both cryptography and formal verification?
Yeah, I think that's a great question. I think one thing is, I think building tools that give value all the way through the process. So the one, there's the bad kind of formal verification, not edges, sorry, I don't mean the bad kind, but certainly one, it's certainly one model is you do 5 years of work and then you get a great result. And that's just not going to work, and I think that can be viable for some kinds of research projects, but it's really important when you're, in our experience working with teams, that you give, the first time you show up, you are able to sort of do something that's useful.
Yes.
And I think that it's that kind of, we need to kind of get away from an all or nothing mindset with formal verification, really. That's one of the reasons that I really like HackSpec, because if you write a HackSpec specification, then that's automatically, it gives you a reference implementation, it gives you kind of something you can test against, and then you can do more verification around that to kind of get more confidence. So I think that building tools that have that kind of incremental kind of feeling to them is good for everybody. And the good thing is that as you build more tools, you have a better ecosystem. And so you can kind of get people on board with it.
Yes.
I think the other thing is, so I think that's kind of sort of, I think that it's tempting for when you're, I was an academic previously, when you're an academic, you kind of want the sort of strongest version of the results. But I think that when you're building tools for industry, our experience is that you really need to kind of build like a toolkit, like a sort of box of tools that all help out. And that's kind of one of the places that these tools are hard to apply at the moment, is they don't have that kind of, sort of incremental side to them.
Absolutely. And again, I don't know if you were secretly in the room on the last call, but a lot of your points are like so parallel to what was discussed on our first call. One of the points made again was we need to address the lack of a toolbox for Rust cryptography. It doesn't necessarily mean having cryptography in the standard library, but a place where people can go to get the Rust cryptography or the Rust crypto that they need. And so again, sorry, who's that?
That's me. We recently improved the testing support in HexSpec, and that can now also with the COG backend easily be translated to the COG part, where you can use QuickCheck, which is a testing framework, which can then also get you into the proving. So you would have the same properties that you first write at the HexSpec level, and then you translate them to the COG level, where you can do both the testing and the proving.
Yes.
So I very much agree that we have a spectrum, and we have very good experiences also with using that spectrum.
Yes. And the conversation from the first call led towards the ideas of having a awesome Rust cryptography site that acts as like a portal where people can pick out the bits and bobs, the tools that they need. And I'm going to apologize for doing this to him, but I'm going to give him a shout out and publicly embarrass him. But Nico is here. Hi, Nico. Great to have you in the room, because this led on to discussions about a vision document and how those can work with helping people coalesce and understand the tools that can be commonly used by everyone. So it's great to have Nico in the room, because that was part of the discussion around vision docs. So I wanted to ask if he wanted to come in, and I can see Greg has got his camera on as well. So Greg will have some points as well. But let me let Greg come in first before letting Nico come in, because that would be like a whole other tangent. So great to have you, Greg.
Thanks. And I think myself will probably lead into the stuff with the vision doc as well, because it's about tools. I do security engineering side by side with a bunch of Amazon developers who are writing a lot of those cryptographic libraries that you've been hearing about. And the thing about tooling for non-experts, I think, is really, really critical here, because for a lot of the specialty stuff, be it cryptography or formal verification, I don't see us reaching a point where some miscellaneous developer, even a skilled one, is going to be able to do it for the more detailed technical stuff for a long time. And so what we really need is tools that people can integrate into their existing workflows and their existing pipelines and existing build tools, and will just work for them with as little effort as possible. S2N right now, which is entirely in C, that's a different story, but it's entirely in C, uses CBMC for everything. And one of our big tasks is trying to have our standard herd of developers, who I love dearly, keep these specifications and these proofs working and in sync with the code. And that's a lot of effort. And it's a specialized skill set, which makes it a lot harder to recruit people, train people, and just keep everything working. And so I want us to think about the lowest common denominator, because a lot of the developers we work with should not have to worry about the details. And if they have to worry about the details, we've messed up. But just like we've seen static analysis become more widespread as the tooling and integration has improved, and the same with fuzzing. And I've even seen interesting unit tests now that, at least in Java, that start blurring the line against static analysis, where they introspect the code in interesting ways at the unit test level, and developers just like write two lines and it does massive analysis. This is, I think, where we need to head if we're going to actually make this usable by more than a small group of experts.
Yes, absolutely agree. Thank you so much. And now I wanted to bring Nico in. It's great to have you in the room. We specifically had a section of the conversation that talked about the possibility of a vision doc for Rust cryptography. But again, I think this now, it's applicable to everything that we're talking about. It would be great to have your insights first on how you see that playing out, your experiences from the async vision doc that you created, which was very popular and well known, and how that process, how we could begin to lead ourselves on that process.
Sure, happy to talk about it. Yeah, so actually I also gave a presentation a little while back where I went through some of this stuff. I think for me, what the vision documents and why I'm advocating for them really offer is the ability to lift your gaze from, well, twofold, I guess. I guess the end state is that you lift your gaze a little bit from where you are and what incremental immediate steps you can take towards that place that you're trying to reach. And that seems like the thing you should always have in mind, and then kind of work backwards from there along. What is the next step you have to take that will bring you closer to that state you want to reach? And my guess is that that state is, fairly nebulous. And so it will probably stay that way, but by writing a doc that's focusing on the experience of using crypto, maybe more than the technical details, you can kind of get that state a little bit sharper and then adjust it as you go based on, okay, we took this step. Now we see that, we had this idea that all cryptographers would be able to use these kind of APIs, but now that we've explored them, they're more limited than we thought. We have to adjust our picture. But let me step back and just sort of quickly articulate what the vision doc's all about. The structure is pretty simple. You have characters, status quo, and shiny future, and then a sort of roadmap. The status quo is basically writing out what is it like today, as accurately and as precisely as you can to use crypto and do the things you want to do. And in some cases that might just be impossible, right? Within Rust, in which case it might be nice to talk about what stops you. Why is it impossible? And the characters I'm advocating for are, pretty universal. They're based on sort of people's backgrounds, but that's still a place of iteration. I think I'm hoping that we can wind up with a series of vision documents for different parts of Rust that all share the same kind of characters, where we have Grace, the systems hacker, and Barbara, the Rust experience person, and Alan, a sort of experienced developer, not systems hacker, and Nicholas coming from a non-traditional background. And but we'll see how that goes. I have to work on my vision doc for vision docs. In any case, what I want to emphasize is that you really start with the status quo, and that's really, really important. I at least found that to be super important, that I learned so much about what people are experiencing now, even when I thought I understood it, that I didn't really understand. Because, usually I expect a lot of people in this room, they're experts on the details. But if you're talking about what does the consumer experience when using the crypto tool you're trying to build for them to use, that might be a kind of different experience than what you realize. And so starting with that, spending some time doing that, what we did was a series of writing sessions, and kind of combined with meetings within companies and other things, reaching out to people and saying, hey, we know you're using crypto, or not, in our case, async Rust. Let's talk about it. Just get some set of people in the room who are actually doing it and let them tell us about their experiences and turn it into stories. And then going from there, and that's the part we're actively doing now, is kind of writing up the shiny future and trying to figure out, the first step, I guess, once you've collected these stories, then you sort of have to synthesize them into one meta story that highlights what seem like the biggest themes. What are the challenges that your people are really experiencing that are most salient? And then go from there to, and how would it be if we replayed that with our, with the tooling we aim to develop? What would be different in their experience? And I think you don't even need to exactly know how that works. For async, I would say there's lots of details I don't yet know, but it seems pretty clear to me that, you should be able to write async functions anywhere you can write functions. That's an element of the experience that should clearly be there. Or you should be able to spawn parallel work really easily. And now there's various challenges that make that not work out sometimes. And I don't exactly know how you can achieve that, but I can write about what it feels like when you have that, right? And set that as the vision. And then when we are working on designs, we can ask ourselves, have we reached that experience, or is this not feeling as good as we want it to feel, and why not? So that's the idea for vision docs more generally. I don't know whether crypto is in this, I think there's probably a right time to do the approach exactly as I described it. And crypto may or may not be there. You all would have to tell me. It might be not yet advanced enough, but my guess is it probably is, at least for some version, and that having those discussions about what is the big shape of what you're trying to build will make it a lot clearer what the next steps are that you need to take to get there.
Yeah, and I think that's a great point, Nico. And that's even on a follow-up. Let's tell Nico where we are with both crypto and formal verification. I wanted to throw this to Tony to just open up on where do we think Rust cryptography is in regards to having this process, a vision doc process for it. And then I will lead on to Bas to also do the same thing. Like, do we feel that the Rust cryptography ecosystem is ready yet for a sort of vision doc? And if not, why not? And what needs to happen for that to move forward a bit? So we'll start with Tony.
So one of the interesting things I think came out of the last call we had, people almost started talking in these sort of terms of like having this like cast of characters, right? And it's like, you know, how do we position libraries in such a way that like library X is for a low-level cryptography expert, and library Y is for like an AppSec developer,
yeah, I remember that.
Who isn't very familiar with cryptography. They need to encrypt something. They don't know the details, and they just want to do everything correctly in the easiest way possible, right? This idea of like misuse resistance and that kind of thing. So I thought that was really interesting. In terms of where we're at, I'm not sure we have a really good story for, you know, telling people if you are like writing an app, here's the libraries you want to use, right? We have like a handful of these high level, like misuse resistant kind of end user facing libraries. Ring is one example. There's also Project Oak is implementing Tink in Rust, which is a library from Google or kind of set of algorithms and a set of APIs. So I think, you know, people kind of understand who these characters are, but I don't know if we have a good story to tell those characters yet. And that's, maybe that's the writing down the current state of the world part. I think it'd be really interesting to kind of seek those people out and ask them, you know, what do you think if you're like not a cryptography expert and you're trying to do some cryptography in Rust? Like, what are you experiencing today? Where are the challenges? Are there clear answers? And just traditionally and anecdotally, what I've always heard is like people are very confused. There isn't really a clear and coherent story. A lot of people say, you know, use libsodium or something like that. A big problem is sodium oxide, which is the main libsodium binding, is kind of unmaintained. Some people stepped up to maintain it and never kind of saw it through and got another release out. So I feel that's like one of the default answers people give, and it may not necessarily be a good one, just given the current state of the world with Rust. So yeah, I think there's definitely some work to do there.
Yeah. I'm just gonna let Bas come in, and then I can see Rick, excuse me, sorry for the mispronunciation, has also got the camera on, so we'll let Rick come in after. Bas, do you feel that the formal verification space is ready for a vision doc process? And if not, why?
I certainly have visions about where things should be going. I mean, if you want to have a 10-year plan, then do something like ComCert, the verified C compiler, but for Rust. And we can clearly see that there are small bits and pieces that are already done, but there's also clearly an awful lot to be done. And just a specification of the language would already be a good start. That's something that we're working on. What I'm very excited about is that we can start small and with examples about HexSpec, and there are quite a few other things that we can already do. And so we've been doing formal verification of the BLS curve, and I think we need more of those small but practical examples, and especially in the standard, we can especially have impact on the standardization process. And I think in your knowledge, there are also a number of possibilities there where people are standardizing, where we can certainly do more.
Yeah, but I think, oh, sorry, just asking you to mute again. Yeah, I think having those examples also meet the needs of the characters that are mapped out will really be a great process as well, because it's also important to have, like, you know, grand generic use cases, but having specific needs met for people who we identify as characters also goes really well. And I think that's what the vision doc does really well. Rich, if you want to come in, please. Sure. Correct me now. Is it Rick or is it Rich?
It's Rich.
Rich, very nice to meet you.
By name, not by wealth.
Okay.
So I think one thing that might be missing from the potential user stories, which could be really helpful, is there is a huge community of C developers who were using things like OpenSSL or TweetNackle or even just Knackle or Tink. And they have come in here and they don't have any guidance as to where to go. It might be too early to do that because we haven't settled down and shaken out to standard sets of libraries. But I think that's an important user community for the growth of Rust as a safe crypto environment.
So let me interject a little. I want to say a few things. First, I think Rich raises a great point, and part of what I'm thinking, part of what I've experienced around the vision doc is you don't have to know the answer to know that you have a goal, that when somebody comes, they have a list of what they should do, right? But you can then go a little further too. You can say, like, well, what are the kinds of scenarios that we expect them to come looking for an answer to? What are those developers doing with OpenSSL, and what are the end goals they're trying to reach? And now they have this tool, but in Rust they don't have a clear. And then that just sort of gives you the paths backwards to what you need. And along those lines, I think CompCert as an example, I think that's a great goal that we should have. Of course, we want to have as much verification as we can, but I'm more interested in what the impact is of all of that. Like, just having CompCert has no impact, right? But having, if we're saying, well, there's standard verification tooling available, what does that do for developers? What does that let them do that they couldn't have done now? We should be able to enumerate the status quo that they're running into and why it's better this way.
Great, yes. Diego, did you want to come in with something?
So not much, but one pain point I currently, or I usually have, is performance. So there is also the expectation that Rust performance will be similar to what is provided by C implementation. So closing that gap is I think, also quite important. And formal verification doesn't necessarily help with that, but Fiat Crypto, for example, in C, does a great job at even beating handwritten assembly implementation. So it's for specific cases, it delivers great performance, but that doesn't translate necessarily to other programming languages like Rust. So closing that gap also would help a lot with adoption and such.
We have Ralph on camera. Great to have you, Ralph. If you want to share what you have.
Yeah, sure. Hi all. I'm Ralph. I'm lead author of Rust Belt, formal verification of some unsafe Rust code, and also in the unsafe code guidelines team, and author of Miri, which is a tool that can check your code for you.
Great to have you.
Thanks. Yes, great to hear so many people interested in formal verification. Yeah. So many customers and juicy case studies for the future paper.
Absolutely.
Right. Bas invited me to briefly mention what they're planning. So one of the things that is on my list for quite some time, and well, I hope to get to it sometime this year, is to at least start on something like a proper spec for Rust. And I don't mean what's in the reference so far, which is mostly focused on like the syntax of the surface language and stuff like that, but the operational semantics. And roughly the plan I have for that is to define a Mer-like language, mini Mer, I don't know, I don't have a name yet, and give a spec for that in a style. So I'm not a big fan of the C specification, so I'm going to try a different style. Hopefully more understandable, but I will obviously ask you all for feedback once there's something to give feedback to. Using a kind of pseudo Rust notation stuff, mathematical notation, but also not just English, to describe execution of like those programs. It'll initially, obviously, it'll be very small, but then once there's a foundation, it's easy to have pull requests for like adding, I don't know, another feature to Minimer. That would obviously just be a tiny part of a full specification. Also, at some point, somebody needs to describe how to translate surface Rust to Minimer and all of those bits and pieces. But yeah, that's kind of my plan currently. And we also have some ongoing work here at NPI about verification tools for Rust in the style of refined C, which you might have heard about, which is a tool where you put annotations in your C code and then it compiles to COC and solves all of the conditions with automatic tactics, which will also be a formal semantics for a subset of Rust defined in COC. And there will obviously be differences between that and Minimer, but those will be bugs. And then we have like, and then we have Mary. So I'm kind of imagining we have like 3 artifacts there that are all specifications in some sense for parts of Rust, Miri, Minimer, and this automatic translation to a COC thing. And then we can like take that as a basis for defining the rest of the language, I guess, in terms of operational semantics. Obviously, there's many other bits like trade systems and stuff which are not included here. Yeah, future work.
Yeah, and just to kind of follow up on that, Ralph, what benefits, would there be any benefits, would it help you with the process that you're working through in, creating a spec to have some exercises similar to what was, developed in the vision doc to help you create the specification? Would there be kind of like pre-spec work that would help, or other kinds of pre-spec exercises similar to what the vision doc is trying to achieve that would help you get to a place where you have a fuller context of what you're creating a spec for?
Nothing that comes to my mind right now, but maybe I'm not creative enough. I mean,
No.
currently it's basically blocked on bandwidth on my side. Like,
right.
If I could just put a hose to my brain and dump it all into the internet, then it will all be done already.
Okay. But you know who you're building for, right? You've already got that fleshed out in mind.
Well, I mean, I guess I'm building for myself. Like I'm a former methods researcher. I want to prove things about Rust. I first need a spec for Rust. So that's what I'm first and foremost building it for, to be able to verify things about Rust programs and to be able to say with certainty that a certain compiler optimization is correct or not. That's kind of the main customers I have in mind. It's not the programmer necessarily directly that wants to figure out like what is this or that Rust surface construct do. I think that's more of a derived artifact. Like from the spec, you can then have people write more accessible documentations that explain things in surface Rust terms. But the normative specification, I think, is well, it should be as formal as possible. And the standard I have there is we should be able to prove things about it, which is why I don't like the C spec, because we can't prove things about it.
Right. That makes a lot of sense.
And then you can, of course, have a derived spec on the level of abstraction of C that then would have to be judged if it's correct against the actual spec. Right? Yes. Like those documents are useful. I just don't think they should necessarily be normative.
Right. Yeah. Thank you so much for that, Ralph. And again, it's so great to see the legend behind a lot of the stuff. So thank you.
Not that much. Thanks.
We're now coming up to time. Things have just whizzed by. It's already on the hour. I just wanted to really give a shout out to Rich as well for what he's posted up in the chat. Don't know how we're handling next steps. I would be interested in working, I think that is, in working on leading a vision doc for C programmers. So Rich, thanks for putting your hand up, because that's one of the things that we're gonna start to flesh out soon. I'm gonna wrap things up here. I just wanted to thank you all for coming and spending time on this call. I hope this has been useful to you all. We're gonna be doing more of this. And we're also going to be fleshing out and helping, the DevX initiative is going to be helping flesh out a similar call, but specifically for the Rust Formal Verification Interest Group, because I think it's an important thing to exist. And I think calls like this and other things around that community should really exist. So Bass and I will be helping out with that effort. Anybody else who wants to help make this exist, in terms of formally helping out planning and keeping things going consistently, it would be great to have that happen. We need to work out a place to have this discussion so that that can be a thing. The Rust Cryptography Interest Group is going to go back to its normal mode of operating on our third call, where we'll be focused on cryptography in Rust. But then hopefully we would have taken some more steps to have the Rust Formal Verification Interest Group exist in its own right and be able to kind of handle its own calls as well. So that's one of the things that we're going to be working on as a next step to this. I'm really excited for all of the stuff that's going to happen in the future, just having more of these conversations and making sure that there's, you know, lots of really cool things happening in collaboration. Nico, I know you have the cross-team collaboration fun times. I always get that. I always get the acronym wrong. I wanted to ask you if you wouldn't mind sharing a bit of that. There's a call coming up on that as well, which again also overlaps with everything that the DevX initiative wants to do. So if you could just share a few words on what that is and when that's happening.
Yeah, so the CTCFT, which for me is not a tongue twister anymore, but for other people sometimes is. It's the cross-team collaboration fun times. That's a Rust. But the vision is it's a call where we talk about things of broad interest to the many different Rust teams, like compiler, language, and so on, libs, etc. And the next one is this coming Monday at, well, it's at 9 p.m. Eastern time. So I don't know where your time zones are around the world. That's tough for Europe, but good for Asia. The next one after that, it's monthly, is going to be shifted. We alternate between time zones, kind of. And the agenda for this week is talking about some thoughts about profiling and debugging tooling for Rust and some of the progress that's been made there, especially for async Rust code, which I think actually is highly relevant to a lot of crypto in practice, at least from what I hear. As well as something else I wanted to bring up, which are guiding principles for the Rust language. So I've been working on a set of principles that are meant to sort of guide us in the way we designed, what are the trade-offs that we have been trying to make and in what order when we proceed with Rust, the language, the library, the tooling, and get them actually written down. And I'd be curious to know how they apply to sort of cryptography libraries and so forth. I think I would expect that they apply quite well. So one of the things I want to do for those is sort of specialize them to different domains. So in async, for example, like the fact that you value safety first or whatever has this implication. And I imagine it might be interesting to look at what that means for crypto. So that's the agenda for the upcoming meeting. And we're going to do some kind of experimental breakout room social hour afterwards. We're not sure exactly how that's going to work yet. Have to figure that out quickly, but hope some of you can make it. And if you're interested to learn more, there's a website, but I forgot what it is. Rust-CTCFT.
Thank you. Before I do finish up, I wanted to apologize to Shady. I know your question was still there. I should ask it now, but like I don't want it to go over time. So I'm going to ask if I'm going to set up a Twitter DM with Tony and you'll ask that to him directly. But I wanted to make sure I apologize to you on the call because we missed your question. I'm going to try and work better on picking out chat questions and making sure that they fold into the flow of conversation. But all of this is a work in progress. So thank you all for bearing with me. I want to thank my co-hosts, Bass and Diego, and of course the legendary Tony. I also wanted to thank all of the people who contributed and spoke. I want to thank Concordium for helping make this happen. And I will put out some more information for the next calls a lot sooner, so it won't be a short notice this time. Any questions, please join the GitHub organization for the DevX initiative. If you DM at the DevX initiative on Twitter, I can add you to that. I can add you to that GitHub organization. So just DM, I mean, I'm the person that's kind of managing that Twitter at the moment. But yes, there is a Rust crypto coordination repo that we've set up, which is there for people to open up issues about things that we've discussed. We may turn that into a Kanban at some point. You know, some of the suggestions that Rich made, for example, could be turned into like a Kanban task as things develop and grow. And again, thank you all for coming and spending your evening or morning, wherever it is in the world for you. Look forward to seeing you all on the next call, both Rust Cryptography Interest Group and the Rust Formal Verification Interest Group. So enjoy your weekends, and yeah, follow at DevX Initiative on Rust, follow CTFC on Rust, follow Concordium and COBRA and Rustlang on Twitter as well. Thank you all very much and enjoy your weekend. Take care. Bye.